Hello, welcome to AB Video 3.9b Part 2, more on tangent line approximation, also known as linear approximation. If you forget the formula, basically what you're doing is this. If they say approximate f of 2.01, what you're going to do is you're going to find the equation of the tangent line to the graph of f of x at 2, the prettier number close to 2.01. And then what you're going to do once you have the equation of that tangent line, you're simply going to evaluate what is the y value on that tangent line when x equals 2.01. And what you'll get is this height, which is approximately the height you're looking for. Okay, so again, I am going to use the formula. It's just easier to use the formula and just plug everything in. Remember, x is the ugly number near the pretty number, and x0 is the pretty number. So, for example, now they're not giving you the function, but they really are. They're asking you to approximate the cubed root of 7 using a tangent line approximation. So, obviously, the function is the cubed root of x. So, our f of x is cubed root of x. This is our ugly number, which is why they're asking us to approximate it. And of course, we want to think of a pretty number close to this ugly number that would be easy to deal with. Well, of course, the cubed root of 8 would be easy to deal with. So, our f of x is the cubed root of x, which is x to the third. We're going to need the derivative. That derivative is 1 over 3 times the cubed root of x squared. We now set up our formula, right? Our x0 is the pretty number 8, and x is the ugly number they've given us, which is 7. We replace all the x's by 7, the x0's by 8. F of x, remember, was the cubed root of x, so f of 8 is the cubed root of 8, which is 2. F prime of 8, we're going to use the formula for f prime of x and replace the x by 8. And then this becomes 7 minus 8, which is negative 1, and the rest is simplification. Okay? So you get an approximate answer of 1 and 11/12. Now, if you had a TI-34, or if you felt like doing long division by hand, you would find out that that approximation is 1.9166. The actual value of the cubed root of 7 is 1.9129 ... And as you can see, our first two decimal places are correct. We're only off by approximately 4 1,000ths. We're off by 0.004. So it's a pretty good approximation. And by the way, in our particular case, 7 wasn't all that close to 8. And therefore, had it been, instead of 7, had it been 7.98, we would have had a much better approximation. Okay, so there is a worksheet that I've given you here because your book has very little on tangent line approximation. You can see number 2 is the kind we just did. So you'll have to, the function is kind of staring at you in the face, and you can easily figure out what the pretty number close to these ugly numbers should be in order to have something easy to deal with. This one right here, it's just the wording. It says find a linear approximation of this function near this pretty number. They're basically asking you to find the equation of the tangent line to this function at that point where x equals 0 or 2 or 0 or 4 or 1. So it's not very complicated. So here we find this, the first derivative, and basically, as I said, we're finding the equation of the tangent line. So you find the first derivative at 1, which is the pretty number that they gave you, and you have to find the actual y-coordinate of the point because they didn't give it to you, so you're going to have to plug 1 into the original function to find the y-coordinate, and then you find the equation of the tangent line. Now, the way you write your answer, however, is it did say find the linear approximation of f of x. They are asking you to say that f of x is approximately equal to. So, f of x is approximately equal to 2/3 x plus 1/3. Okay? And if you could plug something in like f of 1.1. You know how before we wrote that it was equal to f of the pretty number plus delta y, and then we replaced the equals by an approximate and replaced delta y by dy, and we had to go through that whole process. I mean, we still had to go through this process, but at this point, once you have this nice formula, if you want f of 1.01, you'll just replace x by 1.1, or vice versa. If you want a f of 0.09, you'll replace it by that, and you'll have your answer. Okay? So here's me showing you how you could do it just using a tangent line approximation. It's, I think, a bit faster than doing all this. So using a tangent line, use the formula, and of course your x0 is 1. And then you just figure out f of 1, f prime of 1. You isolate your f of x, and you're done. Okay, so another one like this, cubed root of 126. I'm going to go through this quickly. Obviously, the function is the cubed root of x. The pretty number close to 126 is 125 because the cubed root of 125 is 5. So we're going to need our derivative, which I find, and then we write out our formula, and then we replace all the x's by 126. We replace all the x zeros by the pretty 125, etc., etc. And again, you end up with 5 plus 1/75. If you had a TI-34, you'd know that it was approximately this number, and the actual value is here. So look at how close we are this time. 0129, 0133. Sorry about that. Sorry about that. My wireless headset became non-wireless. The battery died. Okay, one thing I want to point out, and you might be thinking, yeah, but if I had a calculator to get from here to here, wouldn't I have a calculator to figure out the actual value? Yeah, well, here's the problem. They're not asking you for the actual value. They want the approximate value. So do not think that giving them the exact value is going to earn you even more points. You'll get no points because you did not use a linear approximation, which, by the way, linear approximation simply means a tangent line approximation, okay? So if they tell you to use a process and they tell you to find an approximate value, you've got to use that process and you've got to find an approximate value, not the actual value. All right, here's just another example. Here's where they give you the function and they say use a tangent line approximation to find f of 2.9. Obviously, that's close to 3. So this is your ugly x. This is your pretty x0. And then you'll need the derivative, of course. And you use your formula. And when it comes time to figure out f prime of 3, you'll go back to your derivative, replace the x by 3, etc., etc.